Okay, let's actually start talking about compositions now. Sometimes you are going to be substituting a function entirely into another function. And you're going to see this notation, and a lot of people call this the fog function. And basically what happens is we're going to get the function g, and we're going to substitute that in to function f. So the substitution actually looks like this. This is actually f of g of x. So it works from the inside out. So g goes into function f. So what I'm going to do is I'm going to plug g into f right here because this is f of g. So g goes in the function f. So let's look at how that works. Okay, so what I have in blue was function f, and what I have in green was the function g. So notice I plugged 2x plus 1 in for x squared, that's what I have here, and I also plugged 2x plus 1 in for x, for the 2x part. Now it's just a matter of cleaning it up. So when I square the 2x plus 1, square the first term, I get 4x squared. I have 2x times 1 is 2x, but double it, and I end up with 4x, and 1 squared is 1. Over here I have 2 times 2x is 4x, and I have 2 times 1, which is 2. Now it's just combine like terms. After combining like terms, I end up with 4x squared plus 8x plus 3. Now you try the next one. So notice here we are plugging f into g. So x squared plus 2x is going to be substituted in for the x right here in the equation g. So when I do that, I get 2 times x squared plus 2x plus 1. When distribute, I get 2x squared plus 4x plus 1. And since I can't combine anything, I'm done. Okay, for the next part, what you're looking for is you're looking for a common pattern. So you need to find a model and what is going to be substituted into that model. Notice here we have an x plus 1, and we have a negative x and a minus 1, which almost looks like the same signs. So what we're going to do is this. Notice we're trying to find f of g, so that means g is going to be plugging into f. So f will be the skeleton of the function. So I notice I have an x plus 1 squared, so I kind of want to look at that. So when I'm finding f, I noticed that I have a term squared, and the minus x minus 1, well, if I make that whole thing a negative x, notice that will end up changing the sign of the x and the minus 1. So when I have g of x, let that be equal to x plus 1. When I substitute in f of g of x, notice I get x plus 1 squared, which is what we have here. And then I have the minus, and then x plus 1, I substitute that in for x here. That gives me negative x and then a negative 1. So I have what could be a possible equation. There might be more out there, and sometimes you'll find more, but there you go. Okay, for this next part, basically what we have is we're trying to find what our profit function is. So basically we need to know how much it costs to actually produce it, and then we're going to find out how much it takes as pure profit, and we'll just subtract the difference. So for part A, to find our revenue function, I'm going to do we have r of x will equal x times f of x, which in this case is 50 minus 0.05x. When I do that, I get r of x equals 50x minus 0.05 x squared. So there's my r of x equation. Now, you know what the cost is, and so to get p of x, we're going to subtract the two. So p of x would equal r of x, which is 50x minus 0.05 x squared. So I have minus the cost function, which is, looks like I'm going to be running out of room here. See if I can move this over. There we go. Parentheses 0.09x plus 12,000. And now it's just a matter of cleaning it up. I get 50x minus 0.05x squared minus 0.09x minus 12,000. Combine like terms, and I get negative 0.05 x squared. I get 49.01 x, and then minus 12,000. So there is my function.